Money FM 89.3, the best of the afternoon update. The Afternoon Update with Lynlee Foo.
Good Wednesday afternoon to you. It's Lynlee. Time for Good Tech, where we spotlight the inspiring ways technology meets purpose, showcasing innovations and ideas that are driving real impact for social good. Now, for someone living with visual impairment, everyday tasks that many of us take for granted, like reading a food label or finding the right shop in a mall, that can be overwhelming. That's where AiSee comes in. It's spelled AiSee, AiSee. Now, created at the National University of Singapore, AiSee is a wearable visual companion that's been evolving over the years. And today, it's entering a new and exciting stage of development. So how exactly is it reshaping accessibility, and how could it pave the way for more inclusive innovation in Singapore and beyond? Joining me to share more is Associate Professor Suranga Nanayakkara from the School of Computing, NUS. Professor Suranga is also the co-founder of AiSee. Prof, welcome to the show.
Thanks for having me in the show.
Now, AiSee has been described as a visual companion that gives users a more natural way of interacting with the world. So can you take us back to the spark, the very beginning? What gaps in existing assistive technologies made you want to create something different?
Right. It was a personal experience. I was taking a class, assistive tech class. There was a blind person taking the class with me, and I was observing how he used the existing tech. For him, it was a smartphone. He would have to unlock the phone, go to a specific application, take a photo, and then the phone app will read out the notes for him. For him, it was okay, but for me, I was like, why does he have to do so many things to read something that we can just seamlessly do? So that made me think, how can we make this whole process seamless and just point and ask questions?
Okay, that's fascinating. Indeed, power of sight is overly underrated, I think. So instead of just adding another device, you were thinking about how to redesign the whole experience.
Exactly. I think that's a fundamental problem with a lot of these accessible features. These devices are never made thinking of people with disabilities, and then they add layers and patching to make them work, and they're suboptimal. So we needed to really rethink how to design something that's truly empowering and accessible.
Okay, you were saying the smartphone apps, many tools already exist, from apps to smart glasses, but they often feel limited. So what are some of the biggest challenges people with visual impairments still face with current solutions, in addition to the ones that you've mentioned?
Let me give you a specific example. When I was talking to one of the blind users who took part in our study, she was like, imagine I'm going to buy something from a grocery store, and then I'm holding the white cane on my one hand, and I'm holding the phone on the other hand, and then I'm holding the shopping basket on my other hand. I don't have three hands to hold my phone. So the hands-free part is a big problem. That's one thing. The other thing is sometimes we have this stereotype. Let's say for a blind person, we say it's always person wearing dark glasses. That's a stereotype. Not everyone wants to wear glasses. Not everyone wants to have things in front of their eyes. So there is a need to build something that's hands-free and screen-free. That doesn't make sense for a blind person to have a screen, right? So that's where we thought, there is an opportunity for us to do something.
Okay, well, very interesting, Prof. Now, for listeners who haven't seen it before, how does AiSee actually work in practice?
So AiSee, you can think of this as a headphone. Some of you might have seen the sports headphones, right? The one that goes around your head and then comes on top of your ear. It's something similar. It does have a camera. So it sees what's in front of you, and then you can ask a question. The built-in camera picks up that question. AI backend generates the answer, and then you hear the answer through open-ear speakers. So basically, it's something that's, as I said earlier, hands-free and screen-free.
So the user would ask a question, and then the open ear design means that the user can hear AiSee's responses clearly?
Exactly. So the AiSee will deliver the response back to user through audio, which the user hear through open ear speakers.
Wow, I can imagine that it blends into daily routines quite easily.
It does, and in fact, it's very important for people with visual impairments because they depend on hearing the environmental sound to have awareness and get subtle cues so that they avoid hazardous situations.
Yes.
And we don't want to cover the ears, right? If you cover the ears, then you take away a very important information channel from them. So instead, we use the open ear speaker, which doesn't cover that information, the important channel for them. So they still hear the surrounding sound, but on top of that, we can blend in the iSee response.
Okay. Was it a conscious decision for you to decide on this open ear speaker system?
So I guess part of our design is pretty much a process of working together with blind people. We really thought, rather than being a technology push, we should co-design. So all these iterations came through as we did our focus group studies and product iterations. And initial version of this actually had a bone conduction headphone, but then there was a comfort factor, there was an issue of sound quality. Now we went ahead with the open ear speaker, where technology seems to be mature enough to provide good quality audio.
Okay, Prof, I understand the latest version of iSee has moved beyond simple object recognition. It now functions more like a digital assistant, reading food labels, translating text, even helping with extended tasks like navigating a shopping center. How significant is this?
Yeah, I mean, the point is, there are doing a device that does one thing doesn't make sense. Then you need to carry one device for each task. Like more things a device can do. And as if you have a sighted companion with you, makes things, a lot more convenient for the users. And on top of that, we also wanted to come up with use cases such as how do you deal with your private documents? I don't want to upload my private document to a cloud, right? That's where we started, incorporating things like these open source Llama models on device. So everything works with iSee and everything processed on your mobile phone, so that you don't have the worry of even sharing sensitive information on the cloud. So they're completely offline solution that doesn't require any connectivity or anything. Those are some new use cases we are building now.
Wow, I think it really broadens the scope from quick moments of help to actually supporting people with visual impairment with entire activities, I suppose.
Yep.
There's also a video mode that supports users for longer activities, like locating items at home. Why was this important for making iSee practical in everyday life?
I think the saying something is in front of you is one thing, but then providing a little bit more high-resolution information, some guiding is important. I think, let's say, for example, if I'm in a grocery store, I want to look for a particular brand of product I want. Just telling it's in that aisle doesn't make sense, right? I need to be able to guide people, okay, it should be the next aisle and it's to your right or it's to your left. That's exactly how a sighted person will guide you if you are in a grocery and ask for help. And we wanted to provide that kind of assistance. You need to work with the video feed and provide this. As I make a step, then the system should tell me, okay, am I going in the right direction or should I go more towards left? It's right in front of you. So that is exactly why we are working on this video mode to provide that guidance. The user can give a target. I want to go get this. The system should guide me to do that, as opposed to just saying it's over there.
Okay. And AI clearly plays a big part in how iSee works. So how important has AI been in making this device possible? And what has it allowed you to do differently?
So when I started iSee, there was no large language models. There was no GPT when we started. So it was very much, you ask a question, you get an answer, that's about it. The moment the large language models came in, suddenly this became conversational. You can ask questions and the system provides the answer. You can imagine GPT on voice kind of thing. And then when we now having to roll out this to the wider community, suddenly the scaling is important, optimization for cost is important. Then, some of these open source models like Llama has become very useful for us, because now, apart from just being a research project, if you want to deliver a service at scale with a reasonable cost, having access to these models help us firstly to deliver these device services at low cost. Secondly, for us to train them the way we want, because these models we have access to the model weight, so we can train them with the data set that we have, as opposed to just sending a request to a black box.
Fantastic. And I know you've been testing iSee with visually impaired users in Singapore since late last year. So what kind of feedback have you received so far? And how is it helping you and your team refine both the hardware and software?
I mean, we have been working with the blind community in Singapore and not only just engaging casually. In fact, in the AiSee startup, we have 2 blind individuals who are employed part-time. So we don't meet them on and off. They are part of the team, and we say we design with them, for them. And specific feedback includes, we made certain changes to make the device more comfortable, and also things like we sometimes, engineers might think of the functionality as the key thing, but when you work with the users, you understand functionality and look and feel are equally important. As much as it should work, it should look nice, the aesthetics, the design aspect, and some specific use cases. One of the use cases is we want to use iSee to allow some of the blind people to get back to workforce. Can we get them re-employed as a museum guide? Can we re-employ them as a guide in a recreational park? That kind of use. Can we get them back as a cashier? So there are these use cases, there are device-specific things, and all this is because we work with them very closely and we develop this together.
Yeah, exactly. Innovation, I think, is strongest when the community has a voice in shaping it. And looking ahead, you're planning public trials at spaces like the Singapore Botanic Gardens, where visitors can borrow the headset to explore independently. So what do you hope those trials will show?
I think, we are super excited now that the main research part is mostly done. Now really it's about impact and scale. And I think Singapore is a perfect test bed. In the next year or so, you will see iSee being piloted in some of the large-scale sites, including the Botanical Garden. And what we really hope to do is, this is really empowering people. And I think really thinking about this, all of us are disabled one way or the other, right? Maybe someone can't see things. Maybe I may not recognize that particular language. Maybe because of the situation, I can't see the things ahead of me because of the mist or other things. So everyone needs support of tech, and I think what iSee is doing is, going into that deployment phase where it will have use cases for everyone. It will start with blind people doing large-scale testing next year, but there'll be use cases for everyone. And we want iSee to be not a device that divides people blind versus sighted. This will be a device that everyone use because there will be a use case for everyone, and it will be a sort of a lifestyle and cool product that really empowers you to be a better version of yourself. That's how we think. We don't see ourselves as assistive kind of traditional classification. We are just building something for people to use, whether you are sighted or blind, for you to become best version of yourself.
Okay, it'll be interesting to find out what you discover from those trials. And finally, Prof, as iSee moves from prototype to broader testing, what does the next 6 to 12 months look like for you? Are there new features or partnerships in the works as well?
Some things are happening in the background, but I can safely say that in the next 12 months, people will have access to get it as a commercial product. We get a lot of support from the university and other partners, and we have actually spun off the company. It will be out as a product next year for sure, even late this year. So people will have it in hand, and I think I want to put Singapore in the map of using AI in a meaningful way to change the way people live. And I think hopefully next 12 months we can create that message and get the enough awareness that we were hoping to create.
Very, very exciting. And I love that Singapore will be part of this. And in the next phase, could just see iSee go from pilot to something that's part of everyday life in a much larger scale. All the very best to you, Prof. And thank you so much for sharing this on Good Tech with us.
Thank you so much once again for having me in the show.
That was Associate Professor Suranga Nanayakkara from the School of Computing at the National University of Singapore on how iSee is combining AI, thoughtful design and community testing to empower independence for the visually impaired. You've been listening to Good Tech. I'm Lynlee. Stay with us on Money FM 89.3.
To listen to more great interviews, download our podcasts at audio.sg or download the audio app. That's AWEDIO, audio at the App Store and Google Play.